today's topic is going to be arterial aneurysms. Arterial aneurysm definition can be a localized dilatation of the blood vessel or the heart. The two main things people forget is localized and heart. Why localized? Because localized essentially just means one specific kind of like a specific area. So aneurysm can occur here. The next thing that you need to mention is that is going to be in the heart. So essentially that it can be something like this. When I meant localized, I kind of went too fast, so I'll just go a bit slower. That it can kind of be like either in the abdominal aorta or thoracic aorta, one place in either aorta. You won't like imagine, you can't imagine like many times in the blood vessel wall. No, it's just going to be in one area. So that's it kind of means specific area. Like I was saying about the heart, people really forget this. They kind of just say it's aneurysm in the blood vessel. No, it's also aneurysm in the heart wall. Why is this? Because there can be myocardial infarction. When there is myocardial infarction over here, it can lead to a very, very weak wall. Why? Because fibrosis. Let me ask you a question: what is more stronger, muscle or fibers? Obviously, muscles. Smooth. I believe there's smooth muscles here. No, cardiac muscles here. Sorry, cardiac muscles here. Cardiomyocytes, and this can lead to aneurysm. It can become weak. It can become stretchable, and it can lead to a dilatation. True aneurysms, they can be true and false. Like I said, two types. I mean, there can be two types. True aneurysms. True aneurysm is essentially going to just be it can just be a dilation, but the key word over here is all three layers of the blood vessel wall. Why all three layers of blood vessel wall? Because if it's all three layers of the blood vessel wall, it's a proper balloon-like dilatation, and it's not a rupture. If you're not going to say all three layers of the blood vessel wall, you can then it would basically you're just saying it's dilatation. So, but if you see all three layers of the blood vessel wall, you're kind of referring to a true aneurysm. Okay, now what are the causes? Of course, there can be atherosclerosis. Atherosclerosis, I will kind of indicate it with some sort of a plaque. So obviously we can have atherosclerosis, and we'll just make it red for explaining, and then it will be basically on the blood vessel. Obviously we can kind of imagine that this is the blood vessel, and the black underneath is going to be the tunica media, and below that is going to be tunica adventitia. So this is going to be here, decreases the blood wall, decreases the blood flow. The decrease of blood flow can essentially cause a weakening of the wall. When it leads to weakening the wall, it might be due to a decreased amount of oxygen. I need to double check why it becomes weaker, but it leads to aneurysm. That's the main point. So that can be atherosclerosis. Another thing can be syphilis. Tertiary syphilis mainly occurs in thoracic aorta. And then the third cause of the blood vessel, and I believe it can be, of course, due to congenital. And then the fourth cause, which is not of the blood vessel, it is of the previous one, ventricular aneurysm, as shown previously. Then a false aneurysm is a pseudo aneurysm, and pseudo basically means not genuine. And false aneurysm is essentially going to just be it's just going to be basically, you can just say it's going to be like a rupture, but obviously that's not a good word. You can just say like the rupture of the breaking of the blood vessel wall leading to extravascular hematoma. And you might be wondering what is hematoma. Hematoma essentially just means, because we always heard about hemorrhage. Hemorrhage means something that's bleeding, that's going on, it's ongoing. But hematoma means the bleeding is finished, it's just a collection of blood, so therefore clotting has occurred. When can this occur? Ventricular rupture. I really put a bold highlight, I'll make it red, because it's ventricular rupture. In true aneurysm, it was ventricular aneurysm. Over here, it's ventricular rupture. Aneurysm means dilatation, rupture means a complete breaking. Over here, breaking of the wall, and over there, dilatation of the wall. What does this mean? If you have a rupture, there's a pericardium, the blood, like you have an aneurysm, then the aneurysm even ruptures, so everything ruptures. Sorry. So imagine there's a hole, this wall does not exist. Then the blood would become a hematoma in the pericardium. Imagine the black is a pericardium. Now different sizes and shape, three main sizes and shape. One is going to be berry. Berry obviously means a berry shape. And this can essentially occur in the circulus of Willis. When it occurs in circulus of Willis, what will it lead to? Intracranial hemorrhage. So hemorrhagic stroke, okay? Sorry for the spelling mistake. Okay, then there's going to be fusiform. What does fusiform essentially mean? I'll put your fusiform over here. Now, look, this is going to be basically fusiform. Fusiform is just basically a shape. So this is the shape. It's kind of like your bicep muscles. Imagine this is the blood vessel, okay? And imagine there's dilatation on both sides. That'll become fusiform. So, but a proper definition would be dilatation, a circumferential dilatation of a blood vessel segment. Blood vessel segment, because this is a long blood vessel, and only a segment is going to be dilated, not the whole blood vessel, a segment of the blood vessel, a diffuse dilatation. And then there's going to be a sac aneurysm. Sac aneurysm basically means a sac. It can be on one side only. So as we were mentioning over here, I would totally delete that, and then I would add a what is a sac aneurysm. I would just make it somewhat like this, and then obviously two for better explanation. This is the aneurysm, just on one side. It's a true aneurysm, just on one side. And it's gonna be 5 to 20 centimeters. Spherical outpouching, contains thrombi and due to stasis of the blood, and the sac is going to be out bulging on one side of the artery. Like I said previously, one side of the artery. Another important thing is stasis of the blood. So the blood, when it is going to, I believe the blood can be, when the blood is flowing here, you can basically stop here because this is such going to be such a big outpouching and bulging. So the blood can basically stay here, it can live here for a while. In a way, this can lead to thrombi. First of all, what are the three reasons of hypercoagulability? There can be a lot of thrombi, a lot of hypercoagulability, coagulability, or a lot of thrombi. When there's damage to endothelium, slow blood flow, or stasis. And I believe there's going to be a third reason, which is not coming to my head right now, but there are going to be two main and a hypercoagulable state. Okay, so these are the three main reasons. So obviously in this scenario we have this one. So there's going to be slow blood flow. There's going to be really no blood flow over here. Can lead to thrombi. Causes of aneurysm, there are mainly 6 main causes. So causes, of course, the main 2 are going to be cystic medial degeneration, which I'll talk about later, and sclerosis and aneurysm, which I talked about previously in this slide over here. Kind of explained over here. And then obviously there can be just infections, so mycotic or syphilic. And have I mentioned? Yeah, I mentioned both infections. And then there can be obviously congenital, so you're kind of born with it. Smoking can also be there because the chemicals, they damage the endothelium. And then there can also be a vasculitis. Vasculitis, there are 2 things. First, inflammation. Second, fibrosis. So if there's inflammation and endothelium, tunica media, and I haven't drawn the tunica adventitia because I don't really think it's that important. But I'm saying that basically stage 1 be inflammation. So imagine a lot of cells come here and inflammation. Then stage number 2 is fibrosis. So imagine the red thing over here, which I'm holding currently dragging right now, is the fibrosis. Makes it very, very weak, more likely to form aneurysms. And there can be increased intraluminal pressure in the artery, which can be lead to hypertension. So hypertension can essentially damage this endothelium. Now mycotic aneurysms, what can this be? Basically, this can be they can form septic thrombi. So it can, let's just say there's an aneurysm over here, it can form septic thrombi, which can then just basically just lead to some sort of a like embolism, you can say. So it forms septic thrombi, they break off, and they basically cause they'll probably go somewhere else into there, kind of cause a block in the blood vessel. So yeah, that's about it. And then obviously there can be a suppurative inflammation, extension of suppurative inflammation. So I'll just draw the suppurative inflammation in like some color, like yellow or something. And it can just be inflammation, again very simple, like nothing very important. And then there can be just some sort of a suppurative inflammation, and there can be some sort of a circulation of the microorganism. So what can this basically mean? This microorganism circulating, and it can basically lead to an infection and aneurysms. The consistent medial dilatation is autosomal dominant, so that assumes that your parents or someone has it, grandparents. What can it be? Basically, there be separation between the elastic fibers and the, what do you call it, the elastic fibers and the smooth muscle. Essentially, I will just make like this, and then I will make like this. So okay, I will just kind of assume that this is going to be the lumen. I will make this over here the media. And essentially I'm just going to be like, okay, let's just say in the media obviously you have smooth muscle and elastic fibers, and like I said, there's separation of the elastic fibers and the smooth muscle. So essentially this is going to be some sort of smooth muscle, and yeah, the smooth muscle, and they're essentially going to be connected by elastic fibers, and elastic fibers can be somewhere like this, but there's just going to be separation. And instead of these elastic fibers are kind of just going to move on to the side, and there's just going to be a cystic type of some sort of cystic type of spaces. So for example, I will just put this kind of like a circular over here, and imagine the cystic spaces. What is it? You must be asking what's going to be inside these cystic spaces. So essentially inside there's going to be proteoglycans and extracellular matrix. So now we've covered everything, and I'm going to be asking you guys questions. What is the definition of false aneurysm? So take your time to answer that. So if you were paying attention, I mean, if you kind of got a concept, you're gonna know that it's breaking of the blood vessel wall, and which can lead to extravascular hematoma. Let me ask you another question. What's the difference between true and false aneurysms? So take your time to answer that. So there'll be two main differences. So obviously false is breaking of the blood vessel wall leading to extravascular hematoma, but true aneurysms can be a dilatation of all three layers of the blood vessel wall. An example, ventricular aneurysm, while an example over here is going to be ventricular rupture. The next question I have for you guys is name what are two types of true aneurysms. So take your time to answer that. Alright, so if you guys have kind of answered that, it'll be the berry aneurysms and a sac aneurysms, which I have mentioned over here. Yep, okay, I didn't really tell you guys these are true, so I'll just make sure this is false. This is gonna be false. I'm not sure though. And I'll make this over here true. I'll just put a T. And I'll make this also true for this. And then I will put the last thing, which what are my other questions? And yeah, I'll just ask you another question. What is sac aneurysms? Sac aneurysms are 5 to 10 centimeters long, and they're essentially just going to be symmetric outpower chain. The main thing is due to stasis of blood. Okay, what are the two important causes of aneurysms? Yeah, so take your time to answer that. Right, so here's the answer: atherosclerosis, aneurysm, and cystic medial degeneration. So these two, and I've kind of gone into detail for cystic degeneration, medial degeneration. And my last question for you guys is: what possible aneurysm can you get due to head injury? So to be fair, I never really mentioned this properly. So take your time to answer. Okay, so if you go on causes of aneurysm, obviously one of the main things I didn't mention over here was trauma, and the trauma can be, for example, head injury. So if you guys found this useful, thank you guys for watching.